Okay, so here we are again. I made another example for you. So go ahead and pause this video and try to solve this on your own. You're going to try to solve for RT, IT, and then you'll try to find, then you're going to need to go into the legs and do that. And just see if you can solve all the different things. V1, I1, V2, I2, V3, I3, V4, I4. See if you can solve all those things. Okay, so I'm assuming you're done with your calculations, and let's check your work. I do recommend you trying to do this on your own because it's a lot different when you try to do it versus when you're just watching it being done. Okay, so if you want to pause and try to do it on your own. Okay, so I'm going to solve it now. So we have, these are in series and these are in series. So we're going to start by looking at, we have leg 1 and we have leg 2. And so if we look at leg 1, here, these together are in series. So to find out the total resistance of this leg, you add them up like you would in a series circuit. So we can say the resistance of leg 1 is 8 ohms. Okay? And then here you can say the resistance of leg 2 is 24 ohms. And now we know that leg 1 is parallel leg 2. So if we want to find the total resistance of the circuit, we can say 1 over RT is 1 over the resistance of leg 1 plus 1 over the resistance of leg 2. That's 1 over 8 plus 1 over 24. So we need to find a common denominator. The common denominator here would be 24. So we multiply the top and bottom by 3. So this would be 3 over 24 plus 1 over 24. That's equal to 4 over 24. So 1 over RT is equal to 4 over 24. If we flip both sides, we can say RT over 1 is equal to 24 over 4, which is 6, right? So we can say RT is equal to 6 ohms. So here we have RT is 6 ohms. So now we have a VT, an RT, and we can solve for IT. So we can say VT, which is 24, is equal to IT times RT, which is 6. To get IT by itself, we have to divide both sides by 6. So IT is going to be 24 over 6, which is 4 amps. So now we have IT, RT, and we were given VT. Okay, so we know that the total current in the system is going to be 4 amps. Now if we look at this, we can say, okay, in a parallel circuit, the voltage stays the same. So if the voltage stays the same, that means that 24 volts is going to be the same on this leg. The voltage of leg 1 will be 24 volts. And the voltage of leg 2 will be 24 volts. So here we can say, oh, we have an R and a V. We can solve for an I. So the voltage of leg 1, which is 24, is equal to the current of leg 1 times the resistance of leg 1, which is 8. To get the current, the I by itself, we would divide both sides by 8. And when we do that, we'd have the current of leg 1 is equal to 24 over 8, which is equal to 3. So that means the current of leg 1 is equal to 3 amps. So we have the current of leg 1, the voltage of leg 1, and the resistance of leg 1. So now in a series circuit, the current always stays the same. So that means the current everywhere in this will be 3 amps. So that means the current through the first resistor will be 3 amps. The current through the second resistor will be 3 amps. And so, hey, we have an R and an I. That means we can solve for V. V1 is equal to I1, which is 3, and R1, which is 3. So 3 times 3, oopsie, is equal to 9 volts. So now let's do a different color. We have a V1, an I1, and an R1. And then here, V2 is equal to I2, which is 3, and R2, which is 5. So V2 is equal to 3 times 5, which is 15 volts. V2, R2, I2. So we're nearing completion. Now over here we say, okay, now we got to look at this leg. Well, on this leg we have an R and a V, but we don't have an I yet. So we can solve for I here. So we can say the voltage of leg 2, which is 24, is equal to the current of leg 2 times the resistance of leg 2, which is 24. To get current by itself, you divide both sides by 24. So that means the current of leg 2 would be 24 divided by 24, which is 1 amp. So the current of leg 2 is 1 amp. Okay? And so now we say, oh, okay, so the current going through here is always going to be the same, and that's 1 amp. So that means the current through resistor 3 is 1 amp, and the current through resistor 4 is 1 amp. So now we can say, okay, well, what is the voltage in these? We have an I and we have an R. We can solve for V. V3 is equal to I3, which is 1, times R3, which is 20. So V3 is going to be 20 volts. And we can say V4 is going to be I4, which is 1, times R4, which is 16. So V4 is just 1 times 4, which is 4 volts. So we have V4, R4, I4, R3, I3, and V3. And that is the end of the problem.